Friends, today we are going to learn binary to gray converter and gray to binary converter. This is our required circuit board. So let us see which part we are going to see in this experiment. So let's see, according to the aim, to build and test code converter using logic gates. So we all are familiar with the logic gates. We all are familiar with the binary and gray codes. The binary is weighted code and gray is non-weighted code. In binary, they have each and every bit have their own positional weight, and in gray code, why this is called as non-weighted, because each and every position they don't have any weight. That's why this is the bifurcation of a weighted code and the non-weighted code. So let's see the objective. According to the objective, which things we need to know about this. So learn weighted and non-weighted code, which we have seen in our theory sessions. Then to get familiar with the binary code and also the gray code, to understand code conversion, binary to gray and gray to binary. So this is our required circuit diagram. So in this circuit diagram, we all are familiar with this XOR gate. Then this is LED and the register. Then so this is our bits B3, B2, B1, B0. Okay, so this is 4-bit conversion is there. So here is why we consider here binary to gray conversion. That means we need to convert binary number into its equivalent gray code. So according to this pictorial representation, so this B3 MSB bit we have to put G3 as it is. So this is the first MSB bit of gray conversion. Then here the XORing of two adjacent bits answering is your next gray code. Then XORing of the next neighboring bits is the G1, and again the remaining B1 mod B0 is also Z0, and accordingly we need to complete the table. In this table we need to represent binary code as per your sequence 0 0 0 0, and the last one is 1 1 1 1. We need to represent this conversion with equivalent gray code. So after calculating, we will observe here how it comes. So we need to complete this table, okay, with the help of experimental process, and again we need to calculate their Boolean equation, okay, with the help of a K map. Okay, so K map is the graphical representation of binary bits. So let's see how to connect the circuit and how to get the observations. Students, let's see here binary to gray conversion. So B3 is as it is your MSB bit. So this MSB is nothing but your MSB. So we need to connect only one wire from B3 to G3. Then in next there is a mod addition of B3 and B2. So we need to add this bit and this bit with this XOR. So we need to connect one B3 to mod input. Again the B2 bit, okay, here the B2 is again connected with the one input of the first XOR gate. Okay, then the output of this XOR gate we have to observe here the gray second bit, second MSB. Similarly we need to connect the next one also. So in this, according to this representation, so there is the mod addition of B2 and B1. So we need to connect one input from B2 and another input from B1. Similarly, we need to connect the mod addition of B1, B0. So the one input is from B1 terminal and the another input is the B0 terminal. So let's see how it works. Okay, after completing your connection, switch on the supply. Okay, after taking the prior permission of your teacher, then here these are the switches which represent 0 and 1. So which input you need to connect? So first 0 0 0 0. After connecting on 0 0 0 0 is there, then you can observe here the binary output. Okay, then after 0 0 0 1, what you can observe across the B0. Okay, So let's see first 0 0 0 0. You will get here the B3, B2, B1, B0, because 0 as it is here, then 0 mod 0. Okay, so 0 mod 0 you will get also 0, then 0 mod 0 0, and okay, here is okay, okay, 0 mod 0 here is also 0. Okay, according to the output of this XOR gate, when the input are same, output is 0. When the inputs are different, that means either 0 either 1, you will get output equal to 1. So let's see the next 0 0 0 1. So according to which bit you are putting as MSB and LSB, if I consider 0 0 0 1, then 0 mod 0, so first MSB bit as it is, 0 mod 0 0, then 0 mod 0 0, and 0 mod 1 here is 1. And accordingly, if I consider the second 0 0 1 0, so 0 MSB bit 0 as it is, 0 mod 0 0, 0 mod 1 1, and this one mod 0 is equal to 0. So accordingly, you need to calculate the steps from 0 0 0 0 to 1 1 1 1. Then you will observe here the gray equivalent of 1 1 1 1 is what? 1 0 0 0. So how it comes? Because we need to consider this MSB bit as it is, then 1 mod 1 output is 0, then 1 mod 1 output is 0, and 1 mod 1 output is 0. So accordingly, we need to calculate all the combinations from 0 0 0 0 to 1 1 1 1. So this is what the conversion of binary to gray. Got it, students? So in our next point, okay, you need to draw the K map of Z3. Okay, so K map of Z3 means according to our previous observation table. So after completing this that means the representation of K map for G3, you will get the output G3 is equal to A is equal to B3. That means you consider here the MSB bit as it is. While considering G2, so this is what the mod addition of B2 mod B3 mod B2. Then the G1 bit is what? G1 gray G1 code, that is what? B2 mod B1, and then next G0 which is equal to B1 mod B0. Accordingly, we need to calculate all these K map, okay, without the considering or solving the Boolean equations. Okay, directly we need to add here the answer of G3, G2, G1, G0. Got it, students? In next point, gray to binary conversion. Okay, so the representation of this G3, G2, G1, G0 with their equivalent binary number. In previous case, okay, binary to gray conversion, we need to add the adjacent. We did the mod addition of two adjacent digits. Okay, but in gray to binary code, we need to take the mod addition of a resulting bit and the next bit. Got it? Next neighboring bit. So there is the mod addition of B3 and G2, then mod addition of B2 and G1, mod addition of B1, G0, and this LSB is as it is, this MSB is here. So accordingly, we need to connect the circuit. Okay, so initially in both the conditions, so we can put here the MSB bit as it is. Okay, then in next point, we need to connect the one here. Okay, you can observe here the mod addition, one input is B3 and another is G2. Okay, so B3 we need to connect the one input of this XOR gate, and in next step, okay, so here is what? Next G2 is another input of this XOR gate. Okay, then the B2 resultant bit, we need to connect B2 resultant bit to the one input of next XOR gate and the next bit with here. Got it, students? Then in next step, B1 is connected to the one input of this XOR gate, and this next G0 is connected to another input of this XOR gate. Okay, similarly we need switch on the supply, and then we need to observe all the conditions from 0 0 0 0 to 1 1 1 1. So this is what we can say here, gray to binary conversion. Okay, after application of 0 0 0 0 is your first condition. Then you can observe here 0 mod 0, answer will be 0. Then 0 mod 0, answer will be 0, and so on. After changing the value from 0 0 0 1, so you can observe 0 mod 0 0, 0 mod 0 0, 0 mod 0 0, but here this and this, that means this 0 and this bit equal to 1. So you can observe here 0 mod 1 is 1. Similarly, when we change the next level 1 1 1 1, then so this is the mod addition of 1 mod 1, you will get here 0. Then this 0 mod 1, you will get here 1. Then this 1, you will get here 0. Got it, students? So this is what we can say, gray to binary conversion. Must remember two things. In binary to gray, we need to add mod addition, or we have to take the mod addition of two adjacent bit, and in gray to binary we need to consider the mod addition of resultant bit and the next neighboring bit. Got it, students? So let us see the observations related with this gray to binary conversion. Okay, so we need to observe only the steps. So like this 0 0 0 0, what you observe practically, you must to note down here. After completing this table, we need to draw the K map. Okay, after completing the K map, we need to observe either pair is generate, either quad is generate, either again the octet is generate, and accordingly we will observe here B3 is equal to G3. Then B2 is equal to what? So B2 is what? The mod addition of G3 is your resultant bit, and then the next bit is what? G2. Similarly, B1 is what? So there is the mod addition of G3 mod G2 mod G1. Got it, students? And B0 is what? So B0 is what? The G3 mod G2 mod G1 mod Z0. So accordingly you need to draw, you need to first clear the idea about how to solve the K map. Got it? So this is the calculation of K map. We have to observe B3, B2, B1, B0, accordingly G3, G2, G1, Z0. Similarly, with the help of this circuit board. I hope you all understood what the exact working of binary to gray and gray to binary using this circuit board. Thank you, students.